Morning, everyone. Thank you for being a part of our virtual conference this year. We have two of our speakers for this talk, Nitya Garg and Akanksha Chaturvedi. Nitya works as
Morning,
a
everyone.
information security
Thank you
engineer.
for being a part of our virtual conference this year. We have two of our
She works
speakers
at
for this
LinkedIn. She
talk,
has
Nitya
about
Garg
7 years of
and
experience
Akanksha
in
Chaturvedi.
information security, most of which has been around building detections, analyzing intrusions, and responding to security
We
incidents.
have
She's passionate about promoting diversity in information security and is also a part of Women in Cybersecurity and Women's Society of Cyber Jutsu, which is dedicated to raise awareness of cybersecurity among women to close the gender gap in security. Talking about Akanksha, she also works for LinkedIn as a senior identity and access management engineer. She has been working in this domain for the past 7 years and has expertise in SSO, Active Directory authentication, and Azure AD fields. Prior to working for LinkedIn, she has also worked for Microsoft and TCS. She's passionate about the domain she works for and likes to explore more about it. They'll be talking about application securities, two features, OAuth and OpenID Connect. During the first half of the presentation, Akanksha will discuss what OAuth and OpenID Connect are, why do we need them, and how do they work. And in the later half, Nitya will discuss about the security considerations that how organizations can protect against them and detect application-based attacks around it. So I'm handing over it to them. You both can start now. All the best.
A very good morning to all present. Thank you, Abhinav, for introducing us. Let me take you through the agenda for today's talk. First, we'll talk about the definition and background of what OAuth is and why is it needed. Then, we'll cover the terminology of actors, tokens, endpoints, and OAuth flows. Next, we'll talk about OpenID Connect and how it fits with OAuth. We will also discuss about the common ways of exploiting OAuth, how to mitigate risks, and detecting abuse. So let's get started. Before starting our discussion on OAuth, I would like to take a minute to explain two common terms, authentication and authorization, known as Auth N and Auth Z respectively. Authentication is the process of validating who you are, whereas authorization is the process of determining what actions can you do once you have been authenticated. Example, when you board a flight, you are first asked for your proof of identity, which is generally the passport. Now, your passport helps in authenticating and establishing who you are. Now, using your passport or the identity, the front desk person or the airport personnel who's sitting there looks for your reservation and the other details. And then you are issued a boarding pass, which has the boarding gate number and the seat number that is allocated to you where you are supposed to be seated. Now, this is authorization that lists the actions and the scope that you are limited to do. Before OAuth, the most common way of authenticating to an application or a website was to give it your password. This pattern of obtaining user passwords obviously had several problems like trust issues, giving blanket access, unable to revoke access, etc. So let's start by taking an example. Consider I made an application called AK My Print that allows you to select photos or documents that you want to print, and my app would print them for you. Now we are taking the scenario of before OAuth. When you access the app, it would give you an option to choose your document or the photo to print from three cloud storage applications: Google Photos, OneDrive, or Dropbox. Now, suppose you select Google Photos. Now, the next screen would prompt you to enter your Google username and password. Now, notice the URL. You will see that it is my app that is asking you for your Google password. And I'm sure none of you want to give me your Google password, right? So now let's take the scenario of after OAuth, right? When OAuth comes into picture. So again, when you access the application, right, it would give you an option to choose your document or photo to print. Now, suppose you select to choose from Google Photos. Now, the next screen would prompt you again to enter your Google username and password. Now, just take a minute and notice the URL. You would see that now it is Google that is redirecting you and asking you for your Google password. So in this case, you are not giving your Google password to my print app. Rather, you are giving it directly to Google, which is the trusted source for your credentials. So what is OAuth in this case? Now, as per OAuth Authorization Framework definition, right, the RFC, the OAuth 2.0 authorization framework enables a third-party application to obtain limited access to an HTTP service, either on behalf of a resource owner by orchestrating an approval interaction between the resource owner and the HTTP service, or by allowing the third-party application to obtain access on its behalf. Now, let's break this definition. So in simpler terms, OAuth is a protocol that allows a user to grant limited access to their resources on one site to the other site without having to expose their credentials. For example, you can grant access to your Facebook account to a social media management platform without ever sharing your Facebook password. So this process, it doesn't know who you are, but it trusts this other provider like Facebook, that Facebook is going to tell me, or the other social media management platform is going to tell me what you are allowed to do. Now, I usually like to highlight 3 points from the OAuth definition, which we discussed in the previous slide. First, authorization. So OAuth is commonly thought of as an authentication protocol. However, OAuth is a framework for sharing authorization. It doesn't deal with authentication at all. Second, security. OAuth framework works over HTTPS and authorizes the applications with access token rather than credentials. So OAuth is great in scenarios where you don't want to share your credentials or maybe any personally identifying information with the target website. And the third and the most important is delegated authorization. So OAuth enables applications to obtain limited access to a user's data without giving away a user's password. So we can say that the user is delegating access to their identity to the application that they are trying to log into. Now, before diving deep, I would like you all to know that throughout this talk, whenever I say OAuth, I mean specifically OAuth version 2.0 and not OAuth version 1. So while OAuth version 1 is still there, but the support for it is fading away. Now let's take a look at the OAuth actors and some other components. So we have 4 actors in OAuth. First, resource owner. Resource owner is the end user who accesses the resource that is hosted on the resource server. Resource server is the web API or the web service that provides access to the resource. Third, the client. Client is a web application or a mobile application that is authorized to access the resource on behalf of the resource owner. And fourth, the authorization server. So the authorization server is the server where the client application is registered and it returns the access token. Now, if we map these actors to our MyPrint example that we just spoke about in one of the previous slides, the resource owner will be you, whose photos and documents will be stored in on the resource server. So the resource server in our case will be Google Photos. Now the client will be the AK MyPrint app, which will try and access the resource server. And the authorization server, which will authorize the app to access this content, will be Google server. Now OAuth also has tokens and endpoints. So tokens contain common information pertaining to the process of authentication and authorization. So most of the tokens have the JSON data format. Now OAuth uses 2 types of tokens, access tokens and refresh tokens. So the first, access tokens. Access tokens are the tokens that the client uses to access the resource server. They are meant to be short-lived. So you can think of them in hours and minutes and not in like days and months. Now, the application receives an access token after a user successfully authenticates and authorizes access. And it then passes this access token as a credential when it calls the target API. Second, the other token is the refresh token. Now, the refresh token is a little different. It's not used to protect the resources. Instead, it is designed so that when an access token expires, you can use a refresh token to request a new access token. Now, one question that comes commonly is what happens if we deactivate a user's account? Now, since the protected resource might not validate the token again, we definitely have a security problem. So this is where the refresh tokens are particularly useful. When the client application attempts to exchange the refresh token for a new access token, an OAuth server, a designated OAuth server, will validate its access. If a user has been deactivated or its related information has changed, our access token will immediately reflect that. Now let's take a look at some of the common fields from an access token. It is mostly in the form of a key value pair since it's a JSON token. Now the first field is the AUD, that stands for audience. This claim identifies the recipients that the token is intended for. Second, the IESS, that stands for issuer. This claim identifies the principal that has issued the token. Third, the IAT, that stands for issued at claim. It identifies the time at which the token was issued. And this claim can also be used to determine the age of the token. Next, NBF, that stands for not before claim. And this identifies the time before which the token must not be accepted for processing. And the last is EXP, that stands for expiration time. And this claim identifies the time after which this token must not be used. Now, these tokens are retrieved from endpoints on the authorization server. So OAuth utilizes two main endpoints. First, the authorization endpoint. The authorization endpoint is used to interact with the resource owner and get the authorization to access the protected resource. And second, the token endpoint. The token endpoint is used by the application in order to get an access token or a refresh token. Now, though I have highlighted only two endpoints in this slide, but there are some other endpoints which are used, such as the token revocation endpoint, which lets us deactivate or revoke the tokens. And then the introspection endpoint, which determines whether a token is active or not by checking the expiration period and the other requirements. Now, moving on to the OAuth flows or grant types. There are four OAuth flows. First, the authorization code grant type. The authorization code grant type is the most commonly used grant type. This grant type is for server-side applications. Second, the implicit flow. Now, in the implicit flow, instead of issuing the client an authorization code, the client is issued an access token directly. And this is mostly used for single-page architecture applications. Third, the password credential flow. In this flow, instead of the client issuing an access token, the client will ask the user for their authorization credentials, which is usually the username and password. And the client will then send a post request with the necessary parameters. And the fourth, the client credential flow. This grant is suitable for machine-to-machine authentication, where a specific user's permission to access the data is not required. Now let's talk in detail about the most common flow, that is the authorization code grant flow. So let's deep dive into the OAuth authorization code flow by taking the example of the print app, which we discussed in the previous slides. Now, the MyPrint app would like to now access your photos from Microsoft OneDrive. In the previous examples, we had accessed photos from Google Photos, but in this example, we are going to access the photos from Microsoft OneDrive. So step one, the client, that is the MyPrint app, it initiates the flow by directing your browser to the authorization server, which will be Microsoft Azure AD in our case. Now, this request contains the client identifier, local state, and a redirection URI to which the authorization server will send your browser or the user agent once the access is granted or denied. Now here in this step, an Azure pop-up window will appear where you will have to enter your credentials. Now in step 2, once you enter your credentials, the authorization server, that is Azure AD, authenticates you and presents you with a consent page that establishes whether you grant or deny the client's access request. Now here, if you see in the example, right, it asks you to consent, allow MyPrint app to access photos, a yes or a no. Now, if you click no, the process stops right there. If you click yes, then in step 3, as you can see, right, the response is sent to the redirect URI provided as step of part 1 with the authorization code. Now, once the application receives the authorization code, in step 4, the client now requests for an access token from the authorization server. And this request is sent to the authorization server's token endpoint, as we had discussed in the previous slide. Now this when making this request, the client actually authenticates with the authorization server using client ID and secret, which it would have provided when it was registering with Azure AD. And the client also includes a redirection URI, which was used to obtain the authorization code for verification. Now, once Azure AD or the authorization server receives this request, what it does is in step 5, Azure AD authenticates the client, it validates the authorization code, and it ensures that the redirection URI that has been provided matches with the earlier redirection URI that was provided in step number 3, to which the code was provided. Now, if this is valid, the authorization server, it responds back with an access token and optionally a refresh token. And finally, step number 6, where the application where the client application actually uses the access token to access the photos from OneDrive. Now let's take some examples of OAuth that I'm sure many of us would have already experienced. So first, when you signed in into SCED, right, to view the Diana Initiative conference details. So when you log in into SCED, you see the options of logging in using Facebook or Google accounts. Now this particular pop-up that gives you the option of using Google or Facebook accounts actually takes into consideration OAuth and OpenID Connect. And similarly, in the second example, if we want to tweet about our talk from SCED that the speakers got an option to, now we need to grant SCED access to our Twitter account. And this we could have done by clicking on the option of tweet button. Now, what this will do at the back end is it will take us to Twitter's page where Twitter will ask for credentials and it will authenticate you. Now, after authentication, Twitter will ask for certain permissions, like, for example, see tweets from your timeline or post tweets on your timeline or see your profile information, etc. Now, Twitter will present these information to us and say, do you authorize SCED to access your account with these permissions, a yes or a no? Now we can click a yes or a no, and depending on that, it generates a token and that token gets passed back to SCED. Now, as a result, what happened in this exchange was that SCED or any third-party tool, for example, it never saw our Twitter password. And another advantage is that the third-party website can only access the permissions that we allowed it to or we consented it to. Now, let me give you a high-level overview on one of the other protocols, that's OpenID Connect. But before we discuss about OpenID Connect, let's think about OAuth once again. So if you would have noticed, OAuth doesn't specify anything about how someone authenticates. It doesn't mention who got authenticated. And this is where OpenID Connect enters. So OpenID Connect, it takes the OAuth 2.0 framework and adds an identity layer on top of it. And it does so by adding an additional token called the ID token. Now, this is a new token type that the authorization server will return, which encodes the user's authentication information. And it also allows the clients to actually verify the profile information and all the identity related information. So since OpenID Connect is built on OAuth, you can do both authentication and authorization using this. And I'm sure all of you might have already used OpenID Connect. So if you log into any website that gives you an option to log in with LinkedIn, Facebook, Google, you've already used it. And it fits well with the example that we discussed earlier about logging into SCED, right? Or logging into my print example using Google. Now let's take a minute to review the same flow for OpenID Connect as we did for OAuth. Now, as in the authorization code flow, we are going to the authorization server as part of step 1. Now, this request contains the client identifier, the local state, a redirection URI, and this time it also contains a scope which has the value of OpenID. So if you see in the diagram on the slide, right, I have highlighted that scope in step number 1. Now, this scope value of OpenID, it signals a request for OpenID authentication and an ID token. Now, after the consent workflow is done in step 2, the authorization code will be granted in step 3. Now, in step 4, this code will now be exchanged for an access token as well as an ID token, as you can see in step 5. Along with an access token, we do get an ID token back. So what exactly is the difference between OAuth and OpenID Connect? Now, OAuth is focused on authorization, whereas OpenID Connect is focused on authentication, and it does not cover anything about authorization. Also, OAuth uses access token and refresh token. On the other hand, OpenID Connect uses an additional token called ID token. So just to sum up all of this together, OAuth and OpenID Connect go hand in hand, and OpenID Connect is just an extension of OAuth. With that, I would like to hand it over to my colleague Nitya, who will be walking you through the security considerations.
Thank you, Akanksha. Now that we are familiar with what OAuth is and how it works, we will discuss how we can secure its implementation. With the increased cloud application usage and shift to working from home, security and how employees access company resources has never been more important. Application use has definitely enabled employees to be more productive while working from home, but attackers are also looking how they can leverage application-based attacks to gain unauthorized access to company-sensitive data. While we are all familiar with the attacks focused on users, such as email phishing and credential compromise, application-based attacks such as consent phishing is another attack vector that we should be aware of. So before we can discuss how organizations can protect themselves against such attacks, let us talk in brief what consent phishing is and how attackers leverage OAuth access tokens to access valuable data on behalf of users. I know that Akanksha talked about what OAuth access tokens are, but let us do a very quick recap. In very simple terms, token is any arbitrary value that represents a web session. We can call it as a session identifier for a web application. Tokens can be strings like ABC123 or some randomly generated ID. But the main purpose of the token is to help a server remember who somebody is. So in this type of application-based attack, what attackers do, they try to trick the user into granting a malicious application access to sensitive data or other resources. So instead of trying to steal the user's password, attackers steal the access token and uses that to access the valuable data. While each attack tends to vary, the core steps are usually like this. An attacker registers an application with OAuth 2. Provider, let's say Azure Active Directory. Then the application is configured in a way that it looks trusted. For example, it will contain the name of a product which is popularly used in your environment, like Google Docs or Microsoft OneDrive. Now what all attacker has to do, he has to distribute the link to his malicious application to the users, which he can do through the conventional email-based phishing. Now, when the victim clicks on the link, he will be shown a consent prompt similar to what we see in the image here. As we can see in the image, the user is asked to give an application some high-risk permissions like reading users' email, sending email on user's behalf, and writing users' mailbox settings. If the user click accept, then they are basically granting the attacker control application permissions to access the sensitive data. The malicious applications gets an access token, which is used to make API calls on behalf of user. A very recent example of this type of attack is a well-known cybersecurity training institute that suffered from a security incident. It was disclosed publicly on 6th of August 2020. And what happened was that a single user was tricked into granting permissions to a malicious Office 365 application. And that resulted in 513 emails being forwarded to an unknown external email address. All right, since we now know that the attackers can bypass the typical username and the password authentication, including MFA, and instead use access tokens to access the data, let us talk about some defense measures that we can take to proactively prevent such kind of attacks. One such step is restricting end-user content. Restricting end-user content is not allowing the users to grant consent to third-party applications and forcing administrative consent for all requests. Every OAuth provider will have its own management portal from where these settings can be done. For example, Azure Active Directory uses Azure portal to configure these enterprise policy settings. Now, if you see on the image, you will see that there is an option to configure user settings for enterprise applications. And when that is set to no, it will disable the users from authorizing third-party applications. We can also set the user settings for user. So they can be configured to disable users from registering the applications. Now, if this setting is configured to no, as shown in the image, users will not be able to register any application with OAuth provider. We can also manage application and user permissions via Cloud Access Security Program. Cloud Access Security Brokers are on-premises or cloud-hosted software that sit between the cloud service consumer and cloud service provider to enforce security, compliance, and governance policy for cloud applications. MCAS is one such solution that administrators can use to manage OAuth applications and user permissions. It enables you to see which OAuth applications have access to what data, which permissions are granted to an application, which all users granted access to what applications. You can also revoke any suspicious applications which you have identified from here. The other proactive measure is to do frequent auditing of OAuth applications. Administrators should perform an audit of all OAuth applications and the permissions they are granted to access the organizational data. This should be done extensively on all applications in order to establish a baseline. Any new or updated application should be periodically audited. If you identify any suspicious application, they should be investigated and removed. And the last, but the most important of all, user training. Users need to be trained to not authorize third-party applications they do not recognize. The user should pay particular attention to the redirect URL. If the URL is misspelled or it contains a sequence of words related to an expected service, the website is likely trying to spoof a legitimate service. Users should also be cautious about the permissions they're granting to third-party application. For example, offline access and access to read emails should excite higher suspicions because attackers can then make API calls to discover other sensitive data. Now let us talk about detection. Even when all required steps are taken to protect against potential attacks, it is important that an organization has proper detections in place to be able to quickly detect and respond to an attack if it happens. Now, there are certain types of actions and events that security analysts can monitor to detect potential OAuth access token abuse. For instance, you can monitor for applications that are granted high severity permissions like user, read, write, all. This permission will allow the application to not only read and write all users' full profiles, but also allow the application to create and delete users as well as reset users' passwords on behalf of the signed-in user. You can also monitor for applications that are sending permission requests to too many users in a short time, which may not be a very common occurrence. After the initial compromise, what attackers usually do, they will try to escalate privileges in search of sensitive or valuable data. Hence, monitoring for privilege escalation action, such as role creations or policy modifications, could be another detection for potential abuse. So we have talked about what actions and events to monitor, but you may be wondering how and where to monitor these. Reviewing audit logs for OAuth provider implemented in your organization is a good place to start with. For example, Azure audit logs store all events related to any change done for resource like users, groups, applications, roles, and policies in Azure Active Directory. Following event types can be monitored to identify suspicious activity related to applications. First event type is add OAuth to permission grant. This event type is generated in usage of OAuth to permission grant. OAuth to permission grant is a resource type that represents the permissions granted to an OAuth application. Second is add delegated permission grant. This event type is generated in usage of delegated permissions. Delegated permissions are those permissions which are delegated to an application from the authorization of a signed-in user or the resource owner. And third is consent to application. This event type is generated when a user consents or grants permission to an application. These event types can be monitored to look for permissions-related activities performed by applications in your environment. And the last two event types are related to service principals. Service principals are same as service accounts, but they are associated with applications. Add application role assignment to service principal is when a service principal is assigned an application role. And add policy to service principal is when a service principal is assigned a policy. So these two event types can be monitored for privilege actions like new policy or new role assigned. Let us take a look on how audit logs look like. Now this is a sample log for the event type consent to application. As explained earlier, this event is generated when a user grants a permission to an application. As we can see on the image, the operation name is shown as consent to application. Initiated by field shows the user details who initiated the action, like username, IP address, and user ID. The application name and permissions granted to it are available in target resource field. Some other important fields include time of the event and the result of operation. So we have talked about what events to monitor in order to identify suspicious activity related to applications and OAuth, and also what logs to review for monitoring these events. And that brings us to the last topic of this presentation, which is writing the detection query. Although the detection query shown here is written in KQL on Azure Sentinel, but with minor syntax changes, you can write it for any SIM platform like Splunk or Elk. So in the first statement, we define a list of high permissions which are not usually requested for or granted. Now that list is given a name as watch permissions. You can choose to give any name, that doesn't matter. Basically, it contains a list of permissions, like a high risk permissions like user read write all, user read all, directory read all. So those kinds of sensitive permissions. And the next statement in the query defines the table name in which we are interested in searching the events for. In this case, it is audit logs. We then check the event type or the event name. Is it consent to application? And next we check the scope or the permission for that application matches the previously watch permissions that we have defined, which contains a list of high risk permissions. So if there are any applications that are granted high risk permissions in your environment, this detection will show all of them. And with that, we open to questions and answers. You can ask us now, or you can also later reach out to us on Twitter or on LinkedIn.
Thank you for the talk, Nitya and Akanksha. I don't see any questions right now, but if someone has any question, I guess they can reach out to you directly. And once again, thank you so much for being around. Have a great day.
Thank you for coordinating and introducing us and handling it so well.
Thank you everyone for joining. Thank you.
Yeah. Thank you. Bye.